Andrew Burroughs has been a consulting design engineer for 20 years, 15 of those with IDEO, arguably the foremost design and innovation consultancy in the world. IDEO uses firsthand observations to inform and inspire its work, which includes the design of the first production mouse for Lisa and Macintosh, as well as the Palm 5. In addition, you can see some of Andrew Burroughs' work at MoMA here in New York. Since 2004, Andrew has led IDEO's Chicago's office, and he is here today to discuss his new book, Everyday Engineering, What Engineers See. Please welcome Andrew Burroughs to Authors at Google.
Thank you. I'm on, aren't I? Okay, so glad to be here. Thanks for having me. I thought we'd start with this. It's lunchtime, and I have a question for you about that picture. Let's see. We'll come back to that question in a minute. So, okay. So, well, first of all, I'll tell you a little bit about the book itself, where it came from, and how it became a book. And Everyday Engineering is its title. It's really not what you might expect, perhaps, in a title of Everyday Engineering. It's not really that much about engineering as the way a lot of people would perceive it, I think. But as you get into it, you'll see what it's about. It's really about, I think, how I personally see the world from an engineer's viewpoint. And it's not just me. There's lots of other people who probably see the world the same way I do. But in my particular case, I sort of come up with a collection of things that other people don't see, and I do see it. So that became an interesting thing. So started off, let's go back to that pastry case there. So some of you may be looking at the chocolate cake with, I think it's some kind of fruit on top or something. Perhaps it was the apple tarts with the cherries there. Very nice, a little tasty. Maybe it was the cream pie there with the dusting of cocoa and the chocolate curls. Or perhaps it was the hinge on the cabinet on the left-hand side that caught your eye. Well, that's what caught my eye. Okay, so that's why I'm standing here, because I'm a little different. Let me tell you a little bit about the origin of the book. It didn't start out as a book. It started out as a conversation in a coffee shop with a colleague of mine. And we're standing there in line, and I was talking to my colleague about this construction of this pastry case that we were standing in front of. It wasn't actually this one, it was a similar one. And I was talking to her about what I saw, which was, I was imagining what it would like to be the person whose job it was to secure this piece of glass, that was a big pane of glass in the front of this cabinet. And there were some screws in there that had to be tightened down to hold the glass in position. And I was imagining what it would feel like to have the job of tightening those screws. What happens if I tighten those screws too much and that whole pane of glass cracks and I get fired? I have to go home to my spouse and tell them that I lost my job because I screwed up. Or maybe I didn't do it tight enough, and maybe the glass would slide over time and I'd get called back in and my boss would get mad at me. And all those, the tension of the moment, like what am I going to, how am I going to get this job right? And there's not just one of those, there's one in each corner, and I've got to do 4 of them, and I've got to get it right every time, and I've got to do it tomorrow and the next day. And meanwhile, while I was having this conversation with her, she was just looking at the pastries. And so we got talking about the difference between us. We're looking at the same thing, we're standing in front of the same view, and we're seeing 2 completely different worlds. And so that was the origin of it. She said, well, that's interesting to me. Maybe you should collect a few more of those. And so I started doing that. Started out with a little collection of mock Polaroids that we put together. Just it was half a dozen things, and we sort of passed them around at the office, and people said, that's cool, interesting, like that. Do some more of that, and then got a little help, and I solicited input from across the company. So there's sort of several hundred people who kept emailing me pictures once in a while and said, this looks interesting, what do you think? And it got gathered into a small collection. It really wasn't meant to be a book, but it looks like a book. We just made a couple of prototypes of this, and one of them leaked out into the wrong hands, and then next thing I know, I get a phone call on my bicycle cycling home from the station one day, and they say, guess what, your book's been published. And I was like, what book? It's just a little collection of photographs. So let me tell you a little bit about the book itself. It's in some ways it's a designed book. It's very plain and matte black and sort of somewhat nondescript in the exterior, and that's kind of how I see the profession of engineering, looking from the outside, looking in. So to a lot of people who are not engineers, I think looking into the engineering, it doesn't look that exciting, to be honest with you. Now, I'm an engineer, so I can tell you that it is exciting, and a lot of you are engineers too, and I hope you feel the same way. And to give a little hint, we put this little detail in the back of the book. a little hint of what's inside. It's a piece of, if you want to call it everyday engineering, it's a piece of construction technology for books. It's been around for decades, and yet it's always hidden by the spine of a book. And so we thought it'd be fun to open that up and expose that to people and sort of show them a little bit about how a book is constructed. And the funny story there is that when we asked for the first prototype of this, it came back and somebody had very carefully pasted a piece of paper over the stitching so you couldn't see it. And that's kind of the point. Like, you know, we want them to see that when people, I want people to sort of experience and know a little more about what's inside a book or a piece of equipment, but yet people see it as ugly and not very attractive. And so they try to cover it up. And as a result, we have less understanding, I think, than we probably should of how things work. So as the collection of pictures kind of snowballed into a larger group, I found them sort of falling into two categories: things that seem to talk about the creation of objects, things that where I could see evidence of somebody struggling over a problem or wrestling with an issue or thinking about a design decision, things that went into the creative process. And then if you imagine how things get built, and I think it's probably true for software as it is true for hardware, once you release an object, you know, whether it's a software release or whether you ship a product from a factory and it lands on a shelf, there's nothing you can do about it from that point on. It's pretty much out of your control. And whether it survives a long time or whether it sort of dies a quick death or whatever, you sort of have to do the best you can to make it live the life that it's supposed to live. But there's lots of forces acting on whatever it is. In the case of physical products, it might be nature, it might be, you know, rough handling, it might be inappropriate usage, it might be all kinds of things. You do the best to design something that can live a successful life and not get too many complaints and make people happy as they use it. But you have to kind of let go of it, and it kind of says out. So as soon as you let go, the process of degradation starts. Things start to wear it down. Things start to impinge on it. The weather takes an effect of people's usage, time, and so on. And so the second half of the collection is really about some examples of things that have been affected in one way or another by their environment and by time. So I'm going to walk you through just a few examples from those two sections of the book, and then I'll be more or less done. So one of the ways things degrade is fire, actually. So the first thing, craftsmanship. I think, and I could be wrong, but I think when most people think of craftsmanship, they think of hand knitted clothing, or beeswax rubbed furniture, or dovetail joints, or whatever it may be, pottery and things. But you look at this cabinet here. It's a telephone closet inside the building that I work in. It's now a disused telephone closet. But there's an awful lot of craftsmanship that went into the construction of this, and the layout, and the hand wiring. In this particular case, you've got a little bit of history played out as well, because on the right-hand side, you've got a punch-down block that was newer technology that came in and made probably a lot of this other box redundant. But even that's got its elements of sort of handwork. And if you look at the detail of how these things are done, that's an awful lot of painstaking work that went into this, sort of laying out the wires, bundling them neatly, carefully routing them all, and with the goal of ultimately just transmitting phone conversations. And all of this is invisible to the user of the phone. So you're on a phone call, you have no idea where your voice is traveling, but in this particular case, it was going through this box, and it was a hand-done thing. Another example, I take the train into work every day, and this is something I noticed one day as I was sitting there. The train I think I ride was probably built in the 1960s, maybe the 70s. And when it was built, somebody had the job of putting this pin into this hole. And this, to me, tells a lot of sort of a story about that process. So the person whose job it was lined that up. They got their hammer out. They hit it a couple of times. They missed a couple of times, and you can see there's a couple of dents in the metal there. And then I can imagine them sort of just rubbing their finger over. Oh, it's a little bit rough. I better deal with that. Get the rough file out. Just quickly, attack it a couple of times with the file, and move on to the next one. But that's sort of recorded in time now. So this is a little story that was played out probably 40, 50 years ago, and it's still captured there, just waiting for someone to spot it. Another interesting area, I think, is what I'm calling unseen. It's really the sort of the things that, and I say unseen, not hidden. So hidden would be something that you really can't see. Unseen is something that might be visible to you, but you're not looking at, you're not seeing, not noticing it. So in this picture here, I'll just leave it up for a second. Anybody got any idea what might be interesting about this picture? What do you see? A couple of doors. Yes?
I see the air conditioning.
Yep, that's right. One of the things I would see too.
The water dripping on the head of the people.
Yes.
Because you see the rust lines, either from a rain or from the air conditioning.
Mm-hmm. Anybody else? Well, maybe not. Maybe not. So I noticed those too. I noticed other things as well. But one of the points here is that three of us that voiced an opinion there, saw different things. And the point is, at least you're noticing something, right? You're paying attention. You're sort of speculating about what it might be. And in this particular case, I look at this. This is the way I view this picture. I see two doors which open into two rooms. And I see two air conditioners of different sizes. And so that, to me, I can read that situation in a way that says the door on the left is either leading to a colder room or a bigger room than the one on the right. And if you're not paying attention, you're not looking around you, you might just go through that door and not really think about it. But it's just a clue. And in fact, if you look at the pipes, the same thing is true as well. The pipes on the left and the pipes on the right, different sizes, different capacities of system. So just sort of a little sort of snippet of information that's there available if you kind of look around, and really it's all about curiosity. Another thing in the same ilk is a piece of classic American automobile engineering, probably from the 70s maybe. And the trim piece that was covering up this stuff fell off, right? So we were never supposed to see these fasteners. We were supposed to just see the trim and then the rest of the car. But when it does fall off and you see these little fasteners in here, they look sort of randomly placed to my eye. No one really expected to expose them, so they didn't pay much attention to how they were going to look when they were exposed. They were only supposed to be seen in the factory. So all of a sudden we get a chance to see this, and you realize, there's another view of this product that is not normally there, but there it is, and we have to look at it, and we have to sort of say, whatever we think about it, ugly or interesting or whatever it may be. So there are some things that I think represent illusions. Here's a bridge in Chicago. There's a lot of these bridges in Chicago, actually. They're all done with the same basic design. And there are people that look at this and go, wow, this bridge is just about to give way. It looks like it's going to collapse because it appears to be sort of sagging very badly. That's because they think that the bridge probably should have a straight rectilinear structure, because it seems like that's the right way to build a bridge. It's a good, solid engineering. And those of you that have some mechanical training will know that it takes a lot more sort of strength and stiffness to maintain a piece of rope in a straight line than it does to let it sort of sag naturally this way. And the bridge is kind of just hanging from a naturally sagging piece of steel. In the case, it's quite a thick piece of steel. So it makes sense from an engineering point of view, but to the layman, maybe this looks like a bridge that's got problems. There's another thing that was non-intuitive to me, actually, when I saw it. It's, again, a piece of a bridge. And in the middle there, that funny little shape in the middle is a hole that's rusted right through from the inside to the outside. You can see through it. And my instinct when I thought about this was that the place that would corrode most freely would be the one that was exposed to the elements most easily, and that the place that would be the last place to sort of get rusted through would be the one that was most protected. But I look at this, and it's so the opposite is true. And as I thought about it, I don't know what the answer is, but I think what the answer is here is that even though the exterior of this beam is exposed to the elements very much so, and it gets rained on, as you can see here, it also gets exposed to the sun very quickly, and so it dries out more easily. Whereas the interior there is just remaining damp that much longer, and the corrosion sets in and never sort of stops. So again, it's like a counterintuitive thing. So interfaces, and this is, interfaces is a much used word, especially in the field of software. I'm talking about mechanical interfaces here, and it's interfaces between inanimate objects as opposed to interfaces between people and objects, or people and software. So here is a piece of a handrail, and I look at this and I see this bracket, this rectangular bracket here designed to go onto a flat wall. Great, that's a good job, a nice simple thing to think about there. And the handrail itself is a reasonably good interface between your hand and itself, so it's a nice smooth round rail. What wasn't so great, in my opinion, in this case, was no one really thought about the interface between the rail and the bracket. And so when it came to actually join this thing up, it looks like they just kind of got the welder in and sort of hacked the thing together. that could have been done differently. Someone could have actually sat down and thought about that more carefully and designed an interface that was easier to use in the field and would be perhaps less messy and not quite so ugly. Here's another interface. Here's a park bench sitting on a piece of soft ground. The park bench was clearly designed to be bolted down to a nice, flat, probably laser finished surface that's just perfectly level. Of course, that isn't always where park benches end up. And so they had to put these little fake flat surfaces in the midst of their soft landscaping. And there's an opportunity that's missed here. I mean, I think this park bench could have been designed with a foot that interfaced far more effectively with soft ground than the one that's in there. But in the process of doing that, might be actually less expensive and easier to install. I mean, imagine if this feet were like tent pegs, for example, and you just sort of take it there, plonk the bench down, and it sits in the ground, and it's very hard to get up and move, and so it does its job, and it's done. So, an interface that is designed for one purpose, but yet it's applied in different ways, and is not necessarily always that applicable in every circumstance. Elegance, elegance to an engineer. Is not elegance to everybody else. This is my mother-in-law's microwave oven and a cup of coffee in there. And I noticed one day when I put my coffee cup in there and I pressed the reheat drink button that it rotated on its little platen. And when I opened the door, the handle was in exactly the same place as it was when I left it. And I thought, is that deliberate or is that accidental? I'm not sure, because I think if I program in a different time, it's going to end up in a different place. But somebody either synchronized those things deliberately or accidentally, I'm not sure, and ended up with sort of a pleasing little scenario, sort of an elegant experience in the sense that I reach in and the handle's where it should be. Perhaps that could be done with everything that you put in there. So you put a plate of food and with a couple of handles on it. Why could you not look at that little piece of code that's running that time cycle? It's 4 minutes and 13 seconds. Why could you not just have that thing stop at the appropriate time so it finishes where it went in and make that process of lifting the food out more pleasing and more, it could be done. So that to me is elegance. And this is elegance too in my world. So there's a very simple sort of throwaway cardboard fruit box here. And what I like about this is the fact that the wire is used so sort of sparingly and so beautifully in many ways. It's used to hold the structure of the box together, sort of from a sort of tensile point of view. It's also used as a hinge, so as the lid lifts up, the wire just bends and creates a hinge effect. And it's also used as a lock, and so you just twist the thing down and it locks it down. So one simple little bit of wire performs multiple purposes and with a minimal sort of complication and simplicity. So that's elegance. Here's a not so good example, I think, of design and engineering working together. Not working together very effectively, actually. A washing machine dial that has a number of programs. I'm sure you're all familiar with this kind of thing. And I feel for the designer in this case, the person whose job it was to put the graphics on here, because they really had a hard time with this, as you can see. Ends up looking pretty jumbled, very hard to read. Numbers are very close together, and spacing is awful, and the icons are kind of splashed in there wherever they can fit them. And the reason it's that way is because, well, the engineer ruled the day in this particular case. The engineer said, I have a mechanism. The movement of the dial is proportional to the time of the cycle. That's the way it is. I'm not changing it. I can't change it. So therefore, you can fit your numbers in whichever way they go. And the result is something that's really not particularly good, I don't think. Could it be done differently? I don't know. Maybe.
Maybe you could finally explain this to me, because I've never understood that. Why are the numbers?
Okay, I'll try. I don't know. I've never taken it apart, but my interpretation of this would be that there's a timing motor in here that rotates the dial around as you go through the cycles, and that motor only runs at one speed. So if you've got a cycle between 2 and the missing 3 here that takes half an hour, and the cycle between 3 and 4 takes 10 minutes, the rotation of that dial is proportional to the time that the cycle takes. So some of those cycles, like the spin cycle, for example, might only take 2 minutes. And so the dial only moves a very short distance in that particular case.
So the numbers don't mean that?
No. I think in this particular case, these would be, these are program numbers. So these are, cycle 11 would be, I don't know, pillows or something like that. It's got feathers in it. So so that they'd be programmed, they'd be appropriate for a particular kind of clothing. Maybe you're asking me a deeper question about how to do laundry. I don't know.
That's essentially what I'm asking.
Okay.
I need to look somewhere else to find where what's the number.
Yes, you probably need to look on the label of your clothing, and even that might not help you that much. But yeah, you want to see somebody else about that problem. And then in this particular case, here's a door that's been designed sort of to fit in with the architecture of the building. It's sort of rectilinear in shape, and when it's closed, I'm sure it looks appropriate for the building. But the structure of that door is actually quite hard to maintain, and inevitably over time that's going to sort of sag because of the way those joints are put together and the effect of gravity and the slamming of the door and so on. So what happened is, somebody saw this happening and came in and sort of had to hobble together a cable system there to keep the door square. So there's an example of how the engineer and the designer sort of came together haphazardly here to create something that still works, still looks good from the outside, but it's not really that well thought through ahead of time. Sort of a after the fact. Sequences. Well, everything happens in an order, right? So some things happen and then other things happen afterwards. And in this particular case, you've got a manhole cover here that was put in the street, probably fairly young. Well, the street probably came first, and then the manhole cover. And then someone came along and decided they needed a white line painted on there. And in this particular case, if you look closely, you'll see there's multiple white lines that are painted on there. And every time it's happened, the manhole's been in a different place. And the result is still not great, right? Because whoever last opened that cover didn't put it back the way the painter wanted it done. They put it back the way they felt was appropriate, which may have been anyway, may have been no thought at all gone to that. Perhaps they tried to line up the little notches there with the stripe because they felt that was the right way to do it, or perhaps it really should have been like that. But they just couldn't do it very easily. Couldn't get it close enough, so they just, to hell with it, it'll get painted over again. But there's a sequence. Sorry?
Does it matter?
Does it matter? It might matter to somebody. Yes, might matter to the person whose job it is to come back and repaint that thing again because it's never quite clear enough. And it may not matter to anybody, to be honest with you. Another thing that happens in a sort of street architecture, somebody laid down a new sidewalk with the nice paving bricks here, and then had to put the signs back in, and the person whose job it was to put the signs back in looked at that and said, okay, it's a little triangular opportunity for me to put my sign in there. I don't have to drill a hole, I don't have to dig a hole, I don't have to custom shape a brick. I can just pop that little triangular brick out there and put my sign in there. Problem is, when he did that, the sign was facing the wrong way. And so as you can see here, the solution for that was just to come along and bend the sign back sort of with brute force to face the appropriate direction. I'm not sure, it might have been easier just to put the sign in the right place in the first place, but apparently that wasn't the direction that was chosen. Then there are some things in the world of engineering, which I'm sure you're also familiar with, that just are very, very difficult to get rid of and solve. And this is one of those, in my opinion. So this is the what's it called? The windscreen? What do you call it? Windshield of my car on a rainy day. And I've been looking through this and past this for years, and all of a sudden I noticed it one day. It's like, what? Why is that there? And this is one of those things that people, my wife, for example, would tell me, why can't you just fix that problem? And you think about it, cars have been around for about 100 years now, and these still exist. So this must be a really difficult problem to solve. In fact, I don't know that we've solved it yet, and maybe we never will. I don't know. This is a place where the constraints around this problem must just be beyond the reach of a nice solution. You could imagine many ways to get rid of it, but there aren't any really great, unless you have Mercedes, and they've come up with some very complex technology which you pay for and they guarantee to be reliable. But in an ordinary car, like the one I drive, you just have to live with it. You could imagine a little wiper blade that will come out of the little gap there just to do that little triangle. But that'd be pretty silly and expensive, and it just wouldn't feel right because it's just not a very efficient way to design a car. So here we are. We live with this thing every day, and most of us just ignore it. This one's a little bit more difficult to explain. The park bench. And somebody obviously had the job of wrestling with what shape should these wooden slats be so that we can lay them out appropriately so we can get a nice even spacing on the seating part on the back. At the same time as going around a corner, at the same time as making sure that the armrest metal there goes through and doesn't disrupt the whole pattern of things. And so they came up with this sort of trapezoid shape of wood. It's quite a clever solution, actually, because from the front it looks very good. It does a good job. It delivers on the promise. But from the side, it's a little dark, you can see that, but it looks a little odd at the back there. You've got these strange shaped openings that open up, and it's not a very intuitive way to lay out the wood. I would not have immediately thought of that as a solution. So another one where somebody sort of sat there and scratched their head for a while before they came up with an answer. So those are all, in my world, sort of examples of things of how things get created and put together. And then I thought we'd talk a little about how things decay and degrade once we've released them out there into the world. So corners, I don't know if anybody here is a mechanical engineer, but I know in my mechanical engineering training, we were sort of grilled on corners. So almost as soon as we walked in the door, corners are bad because sharp corners are weak and they break very easily. And sure enough, on this outlet cover here, we've got 4 sharp corners that they're missing now because they broke. And what makes it even worse is that in this particular design, whenever that was locked down in past history, it was sort of sealed and done with, and we may never change this. It may be here for, I don't know how long it's going to be here, but a long time, I suspect. And so as a flaw that's been designed into this particular very ubiquitous everyday object here that we can't get rid of, and we have to live with it, and we have to live with these kinds of things as a result. Another example of how corners really don't work is you probably see this everywhere you walk, but this little square street cover here, it's got sharp corners, and you can see there's a crack emanating from every single corner. Not just one, but they've all got cracks in. So just to, sort of drives home the point that, avoiding corners is good, but they're actually kind of hard to avoid. There's lots of things that just need corners. You can't get around them. They sort of show up in everyday life. Everything can't be straight or curved.
Sorry, what effect were we observing there? Why do cracks radiate out from the corners?
Stress concentration. Yes. So when you have a sharp corner in a piece of material, if you had a straight piece of material, for example, and you sort of just pulled on it and tugged on it, it would have pretty good strength. As soon as you sort of put a sharp corner in there, at the very sharpest piece of that corner, the stresses spike very highly. And so as you put it under the same stress overall, the same load, it's likely to fail immediately because of that stress peak at the sharp corner. And so in the street here, this is probably the stress of cooling and freezing of the road. This is in Chicago, so it gets cold. And as it does that, the weak points at the corners here start to degrade and break down, and finally the cracks just start moving out from there. Ugliness. So some things just end up being ugly. Here's a factory. It's not a particularly nice factory, I have to say, but somebody did at least try to make it look decent. They put some decorative bricks there and even painted half the drain pipe with the beige color there, not the rest of it, just the half that's top there. But then if you step back from this factory a little bit and view the whole thing, on top of the factory, you've got this really ugly mess of ductwork and fans and pumps and things that sort of is very incongruous with the appearance that the street level factory has. I don't know if it has to be this way. Maybe there's a different way to do this, and why can't we give some of these things the same attention that we'd give the street level on the ground and the sort of the immediate experience? And there's another one. I think ugliness could also sometimes be called just laziness would be another way to characterize this. So here's a bunch of wires that have been there for a while, apparently. The pole needs replacing. It'd be a lot easier if you just don't replace it and just kind of hijack it with another one. So they just figured they'd put a new pole in here and lop off the old one and hope nobody would notice. Well, somebody saw it. Materials have interesting properties. This piece of metal pipe here acts, this is the way I see this as a sort of a three-dimensional recording device that records all the interactions it has with its surroundings. So every time someone bumps into it, scrapes against it, knocks it, brushes it, gets corroded, it's taking a record of that and kind of capturing it in a kind of little history book. That's sort of, this is the life of I'm a pipe and this is my life, and it's been a rough life, the looks of it. So, and this piece of wood is telling a story as well. It's raining again today, and the outside of that wood got wet, the inside is dry. So the outside expanded more than the inside, and the wood curved in the direction of the rain. When it dries up, it'll probably go back to being flat again. But it's sort of telling a little story there about its property as a material piece of wood. When things happen over and over again, when it happens once, you don't necessarily notice it. When it happens over and over again, you might notice it. So there's another question I have for you. What do people see on this picture? Anything strike you on this one? The lines aren't straight anymore. Good. Let's just go with that. So as the traffic has moved over this cobbled or this paved road for probably 70, 80 years since it was put down there, the bricks appear to have moved in such a way that it's almost formed an S shape here. So they gradually just migrated in opposite directions in the direction of traffic over time. Something you wouldn't notice on a daily basis. You'd never be able to measure it, just imperceptibly small movements taking place. But over time, it builds up into something that's, actually tells you which way the traffic's going.
Would you expect the opposite?
Sorry?
Would you expect the opposite?
Would I expect the opposite?
Because the car is pushing.
Yeah, you might. I mean, I don't. Depending on where it is in the street, if you're accelerating away from a stop as opposed to braking, maybe you might be putting a force in the opposite direction. It could.
Braking happens more intensely than acceleration.
Yes.
Big forces during braking would be greater.
Yes. So what I would expect would not be the opposite so much, but I think in my view of the world, I would expect nothing. I would expect the road to sit where it was, but we put it in, just stay put, right? And most people will probably think the same thing, but in fact, that isn't really the case, according to this anyway. Here's another one. This is a bad picture of a light fixture on the train again. I spent a lot of time on the train, you can tell. And in this case, the old fluorescent lights, some screws inside there have fallen loose inside the light fixture. And over the time, as the train's been going up and down the line, they've been moving and rocking. And if you can't see it from this picture very well, but up close, if you look, there's little semicircular gray arcs sort of worn into the inside of the plastic light fixture as the screws just rock backwards and forwards there. Now, what's going to happen next, I don't know, but someone's going to come along and change that light bulb sooner or later, and those screws will probably fall on the floor and get swept up with the trash and be gone. Or maybe they'll be noticed by somebody and they will get picked up and put back in, but I doubt that's going to happen somehow. So it's sort of a little marker of things degrading, and yeah. So another one. The pattern on the floor here is really, again, a record of the directions that people move as they walk into this building here. So it's not particularly surprising, but they're coming straight through here. Some of the people apparently take a right turn, but most people go straight ahead, and some people sort of take a left turn because the pattern is not a particularly interesting pattern. But the point here is that it's really a record of repetitive actions happening over and over again, just creating an image or a record of what's been happening that otherwise wouldn't be noticeable if it was just a one-time thing. And then small things can lead to bigger things. Here's a tree that's planted in a little metallic grating here, slightly off-center, you'll notice. Doesn't look too bad at this point of view. But as the tree grows, it gets bigger, starts to bump up against its surroundings until eventually you get something like this happening. And that's really noticeable all of a sudden. That's a big sort of aesthetic impact on the beautiful streetscape in Evanston, wherever this was taken. And if you think back to that first image there, how much time would it have taken to just move that tree over about 2 or 3 inches to get it more centered to avoid this kind of thing? It probably wouldn't have been that difficult. It would take just a little bit of time. But then 60 years down the road, you've got this effect that happens that sort of plays out in a much bigger way.
Is that the same tree?
No. I am not that old. Here's another one. This is the flagpole outside Boeing's headquarters in Chicago. I actually got stopped while I was taking this picture. I'm not quite sure why they were worried about it, but maybe they were guilty, because it's a beautiful flagpole and it's in a very nice location by the river, and they put a lot of time and energy into creating this plinth out of stone. It's painted. It's all nicely done. And then whoever put this flagpole up just looks like they grabbed some scrap metal for washers and put them in there, and then they just let them rust. And it really spoils, what could otherwise be a very nice installation. And to me, that's just it's a real shame. I mean, why did it end up that way? Was it their fault? Did they just not get the parts shipped to them when they were doing their installation appropriately? Were they just couldn't be bothered to do it right? Not even the same washer. Looks like there's at least 3 different kinds of washer on the side of this thing. They got all the stuff they need except one little piece, but they just kind of went with it. And the result is this, which is really, detracts from the overall flag experience. And then as we sort of put things out there in the world, nature is going to get the better of us eventually, one way or the other. There's no question about that. Here's another picture. Anybody see anything interesting about this picture? You have to look closely.
It's sunny, yet there are raindrops on the window.
Yeah, you're right. It does, doesn't it? No? Well, let me help you out a little bit. If you look at the raindrops on the window, you'll see that they're sort of unexpected, they're coming down at an angle, no big surprise there. But if you look a little bit more closely, you'll see there's also some raindrops that are going at this angle on the same window at the same time. And I happened to glimpse this as I was looking out the window one day, and what I realized was the train had just come to a stop. So as it started to rain, the yellow drops had hit the train while it was traveling at speed, and as soon as we stopped, the white drops had come down at a different angle. And so just played out in front of me on the windscreen, on the glass there was this little sort of velocity measuring device that was made of rain and window pane, which for an engineer, I guess, is something worthy of note. And then there are things like this that you see everywhere, small, seemingly insignificant little seedlings sprouting in strange places that, eventually grow into much larger things and have much bigger effects and have much more sort of a devastating effect on the things that we put out there. And, there's nothing we can really do about this. Like I said, nature is going to tear it all down to dust sooner or later. So we have to get used to it. But, there might be some things that we can do to maybe work more cooperatively, perhaps. And then just the effects of time, I think, are interesting. Here's a barn that used to be near where I live. And you can see the roof's in pretty bad shape. It's sagged very, very badly. And what I would have liked to have done was show this picture to the people that built the barn and said, this is what's going to happen to your barn. While you're building it, why don't you factor that into your construction techniques and see if you would change anything? And I think they probably would have done. They would have looked at that and said, oh, crazy, we've got to beef up that ridge beam there and do something. But obviously I can't do that. But the lesson here is that if we look around us and very observant, we can see things like this that will kind of teach us lessons beyond where we might normally get them from and hopefully build them into the things that we do. And then here's a screw that's again, gosh, a lot of train things here, too many train things. This is a screw that I happened to notice that's just about fallen out of its hole. And I had to wonder, so how many times did the train go up and down the track to get it this far? It might be, I don't know, it could be hundreds of trips. And slowly each trip it's just backing out just a little bit, until one day it's going to plonk on the floor and be gone. But just, so why is that screw falling out and the other one not? Somebody that day just twisted it a little tighter on the left and on the right. I don't know, but there it is, sort of one of those things that you see around that happens all the time, and so time accentuates some of those things and makes them show up in a way that we wouldn't otherwise notice. So those are some examples. There's quite a few more in the book itself. Lastly, I'd like to sort of show you a couple of cartoons. So you've probably all seen these before. Some of these might even be. And there's another one. And then one more. So the point here is very easy to pick at engineering as a sort of a career and a job and a life choice. I think we get made fun of a lot. And I would like to think that if we all sort of open our eyes and think a little more broadly about the way we think of our career and as engineers, that we can kind of swing the needle back in a more positive direction over time. So that's it. Thank you.
I noticed when I picked up your book, there's sort of a textured dark surface, and I wonder if this surface was considered, you talk about degradation of items. When I see this, I can imagine sort of the story of the book being marked on its cover even more so than a standard book cover. And I wonder if that went into your design.
Yeah, we did consider materials very carefully and tried out a few different things. We ended up with this one for a couple of reasons. I think it was sort of an interesting tactile surface, but it also reflects back some of the things that are happening to it very sort of effectively, you might say. It shows fingerprints more easily than some things, and somehow I kind of like that. It sort of shows the book's been handled and used. And you can also see some of the construction of the book through it. You can see how the liner paper has been wrapped on the inside and folded. We did think sort of fairly carefully about, so this is a book about engineering. How is the book going to be engineered? Because people will be scrutinizing that. And for whatever purposes, it ended up with this material. And then, any other questions?
Please step up to the mic.
What have you learned about creation from degradation?
From degradation. I think I like to, the lessons that I draw from that, I think, are that things like time is a very easy place to look. The effect that time has on the way materials wear, the way shapes change over time, the wear patterns. One of the examples I like to use is that things, when we design buildings and structures and products even, we tend to always make them rectilinear. So we make vertical surfaces vertical and horizontal surfaces horizontal. But when you look at how they behave over time, horizontal things nearly always end up, tilting. They cantilever. Very often, if you mount a light fixture to a wall, for example, and it's perfectly flat when you start out, and you can see examples everywhere of this, before too long, it starts to droop down, and gravity takes its effect. And so one of the things I've learned from that is that, and I haven't used it yet, but I'd like to someday, is actually to think about perhaps correcting that before it happens. So maybe we should actually be thinking about designing things with just a little bit of an upward tilt, so that we're ahead of gravity by just a couple of iterations of degradation, and we can have the thing settle down to a point where it actually is where it should be, as opposed to start off perfect and it's all downhill from there. If you put something in exactly the right place, it's not going to ever be there for much longer. It's going to gradually decay. So is there a way to sort of engineer things so that as they settle into a wear pattern, that's where you want them, as opposed to sending them out? I think you get the point. So anticipating degradation and anticipating the performance of the particular thing as it is sort of in its worn out mode, rather than its pristine, just being shipped out the door mode. One example. Any other questions? Yes?
I don't know quite how to ask the question.
Please use the microphone. It's being video conference.
So the pictures seem a bit more bleak than I anticipated from the title of the talk.
Yes.
And it seems to me that when I look at things like this, I often just marvel at the ingenuity and the accumulated experience, like that roads are curved and they drain well, and if I would build a road without that experience, it would flood.
Yes.
And I don't know how that kind of optimism about, I usually get the sense of optimism like we're making progress over time, and
right.
And things are, and yet I look at these pictures and the screws are falling out and the roofs are sagging, and I wonder whether you have this sense of optimism or a sense of just that this is that everything really is in decay. I don't know.
It's a great question. I am an optimist by nature, so I think I am optimistic. I don't think I look, and that's partly me too. I sort of enjoy landscapes that have decayed. I don't like things all to be too nice and clean. So that's partly just where I sort of find myself wandering around and the things that I'm attracted to. I do think it's I feel optimistic about it. I think if we understand as much as we can about the way things behave in the world and how they decay and degrade, then we're just going to be that much better off as designers and engineers think about how we're going to do the next version of that. So although I look at it as lessons from the past, one of the things that we say at IDEO a lot is fail early, fail often, and we view that as a very positive and enlightening step in the process. So by studying failure, which is kind of what you're suggesting I'm doing here, I'm looking at all the sort of bad examples of things that have not worked very well. I think that sort of looks to me like a store, a store of useful anecdotes and ideas, things that we can put into use as a designer to kind of prevent it from happening next time. So next time I design something with a screw in, I'm going to be thinking of that picture where it's loose and thinking, what would I do now that's a little differently? How would I prevent that from happening? How might I take advantage of that somehow? Maybe I'm going to assume that it's going to back out, and if I do, how would I design the product so that that could be non-catastrophic as opposed to, just leaving a hole and the thing falling on the floor. So yes, you're right. I mean, I think there is a sort of the tone of a lot of the pictures is a little sort of bleak. But the flip side of that is, from that becomes something new and better.
Time for one more question.
Okay.
All right, so thanks to everyone for coming, and there will be a book signing in the back.
Yeah, thank you very much.